Okay, hey everyone. It's exciting to be here. This is our first keynote talk with Redspread, and the first time we're talking about this idea of versioning environments. And so, versioning environments with Kubernetes. I'm Mackenzie, co-founder of Redspread. Dan's my other co-founder. And yeah, let's get started. So in general, we think it's a best practice to version control different parts of the development process. So we version files with Git and GitHub, images with a container registry. And the reason why we do this is because we're trying to track changes to differences in environments, so it's easier to collaborate, and then when something does go wrong, to quickly go back to an earlier state. Sorry, this is like super basic, just an overview. What is an environment, right? We generally think of it as the code, the data, the configuration, the operating system, and the machine. And with containerization, this is actually abstracted away the operating system and machine layer. So really we're just dealing with the code, the data, and the configuration. And so let's just rearrange that here. And imagine that versioning an environment requires you to version these three things, right? The code, the data, and the configuration. So container registries make it really easy to version code, right, with images. Kubernetes has provided a really great abstraction, or a great way to version configuration through their objects. And the data part's a bit trickier, right? Versioning data is obviously an unsolved problem. It's super application specific. Some companies like Pachyderm and ClusterHQ are solving it for very specific use cases. But between the code and configuration, it's possible to specify an application-specific data versioning. And so it gets back. So then we get to this idea of like why version environments at all, right? Which it guarantees reproducibility, portability, right? It's really easy to spin up new environments when you have like a commit that you can reference. That's exactly what it should be, right? It makes it a lot easier to collaborate around deploying code and prevent mistakes from slipping through to production. And so I'm going to get to a demo here, actually. So this is sort of how we are attacking this problem at Redspread of versioning environments. And so, okay, cool. So here we have just a application. It's a simple website with an RC and a service, and All right, so here what I'm doing is I am starting, let's see if this works. This happened.
We'll just use a real cluster.
Oh yeah. So this worked like 2 seconds ago, but obviously when we're trying to do it, it doesn't work. Cool. So here, hold on just a sec. Let me switch to this laptop. Cool. Can you see that?
You're trying to show the drum.
Okay, cool. Is this big enough for everyone? Oops. Cool. All right, so I'm just going to get into my repository. Cool. So here's my application, and let's make sure that Docker machine is started. Cool. All right, so actually I knew that this was going to happen, so I've actually recorded a demo of this. So, so here we go. Yes, this is a version talk. So here I have started a local cluster. Local cube is Redspread's cluster, like local cluster that we have. And actually, if you've heard of Minimill, we're working with Kubernetes to roll that in, or Minikube. Working with Kubernetes to do that. And when I did spread deploy, what it did was it's just spread as our command line tool. It deployed all the objects at the same time to the local cluster. And you can see that I have an RC running, and then I have a service running as well. And so the next thing I'm going to do is the versioning part, right? So what I'm going to do is I'm going to use spread to then add the object to the RC. So staging it the similar way that you do get add file. This way you do spread add object. So I'm doing both the RC and the service. And then I'm going to commit that with a commit message, just like you would do with Git. And then here, what I'm doing is I'm pushing it to a remote spread repository, so to redspread.com. And so here, effectively, I versioned my cluster, right? And I versioned it at the object level, not at the file level. And the reason why this is good is because the reason why we're doing this with Kubernetes is because a cluster essentially is an environment, right? It's a really great abstraction level for dealing with environments. And Kubernetes objects provide deterministic configuration, right? So the code you can think of as images, right? The configuration are like all the fields that you have to specify, and the data can be versioned in sort of an application-specific way. Now so we get the idea of like, okay, it's probably a good idea to version your environment. Kubernetes provides this way that you can version the environment, like that your cluster can be treated as an environment. So then it gets to, then what's the best way to version the cluster? And what we think is the best way is to version the object itself, not just the file. So you could do this with Git, and in fact, a lot of companies are, when they're working with Kubernetes, are versioning their environments using Git, right? Sort of hacks around Git. And versioning files are great because there's this human readable interface, but there are so many different ways to get to the same state, right? You can get to it through YAML or JSON or scripts or JSON.NET, right? Objects are the concrete representation of state, right? And so we think they provide a better level of abstraction when you want to version the entire environment, because you can actually have a one-to-one mapping of a cluster. Now you can take two arbitrary clusters, diff them, and without having to parse any of the files and trying to diff those files, right? You can actually just understand the differences between two arbitrary environments or arbitrary clusters whenever you want. And also provides better context, right? The same idea of like anyone knows about linked data, like the concept of the semantic web is that you can actually bring context to the information that you're sharing and collaborating around in a way that machines can understand. And so some immediate possibilities when you can version environments is that it gives better resource management, right? Like you can reproduce environments exact copies of environments at will. You can spin up and spin down environments really easily. It's easier to track drift, right? We can monitor clusters now with the Kubernetes API, so we monitor what's in Kubernetes and track that against an expected state, which is this commit, right? So you can tell actually when things change and when they're different than what they're supposed to be. It's really easy to do rollbacks, right? It's just simply rolling back to the latest commit. Bug reports suddenly become really easy because commits are reproducible bug reports, right? And auditing becomes easy when you can now track changes to commits by just searching through, or deployments by just searching through commits. And so this is the question I wanted to, we think the community should be asking themselves is that when things like this are easy, when you can actually version environments with Kubernetes, what comes next, right? How can we think of a world where you can easily compose and distribute complex applications, like spread, deploy, Hadoop, for example, is something that we want to make possible. And so what comes after we make things with Kubernetes easy? And I think that's sort of the world that we all want to try to envision in, but it's really important to have one foot in the door in that world so that we are prepared and we are building for the next stage of computing, which is why I think Kubernetes is really interesting. So that's it.
All right, so thanks for coming, guys. You guys excited? You guys excited about this topic? Yeah. Don't lie, come on, networking, come on. Thanks, guys. That's my life's work in the slide deck. Okay, so solving Kubernetes networking with Open Contrail. So bear with me. We're going to have a lot of fun with this. So first, whenever I go to meetups, I like to level set. What are you going to get out of the next 20, 25 minutes with me? So bear with me. Can we just turn this mic down just a little bit? Yep. If you wouldn't mind. I'm feeling a little bit of feedback. Thank you. Is that okay? I have a loud voice anyway, so I'm sure I'm Australian. I'm obnoxious by design. So level set. So first thing I always ask of any audience is I invite dialogue. I can sit here and talk to you for 30 minutes, or you guys can get interactive. So I figure if you're at a meetup, you want questions answered, and that's what I'm here to help you with. So, you know, feel free to interject, interrupt, call me out, put me on the spot. No holds barred. Okay? We okay with that? Cool. This is not a sales pitch. This is from being in the trenches. So I'm not here to sell you something. I'm here to show you and speak of my experience and my journey with Open Contrail. I'm not saying this is the best solution in the market. I'm going to show you why we chose this solution. So I really want to bring you on that kind of journey and just give you that kind of perspective. So quickly, Kubernetes for us at Lithium Technologies started about a year ago. So June, V1 Kubernetes. It's hard to believe that this was only last year at 1.3, and it seems like an eternity ago. It's good news, right? It's actually developed a lot from 1 to 1.3. So I was up in Portland at OzCon speaking about our experiences this time last year. So we've been in the trenches with Docker, Kubernetes, container orchestration for about a year. So I'm bringing that kind of context in. Not only have we been in the trenches, we've actually run production workloads using Open Contrail. So you can ask me things, but just think about that as a starting point, because the market has moved a lot in a year. So I know the CoreOS is on tonight. They're speaking about Canal. Love the Canal, Calico, Flannel integration. That stuff's great too. But we were making a decision a year ago. This stuff wasn't there. Or it was in its infancy, let me say that. Okay. So I always throw this up. What is the biggest challenge with Kubernetes? Running it on-prem or outside of Google? Can anybody answer? It's a leading question. Networking. And why is that? Why is that? Does anybody know? You look at Mesos, you look at Swarm. It's host ports. You don't have to run layer 3 networking to host ports. You just have to know how to route to hosts. Every network in the world knows how to route to other hosts on the network, right? Problem solved. But have any of you guys ever run Mesos or Swarm? You have to run a service registry to register ports, right? You know, anybody got a good solution to how to deal with that? If you want 2 containers on the same host binding to port 8081, Brandon might have a good idea. But you have to go build something yourself. It's not fun. So one of the greatest things about Kubernetes is that you have an IP per pod, right? This model is actually ingenious, but what it imparts is you need your network to do some heavy lifting, right? And that's the challenge. So, you know, while it's great when you're on GKE and you just spin up a Kubernetes cluster and everything magically works, how many people are using GKE here? It all magically works, right? It's great. Maybe some little things about load balancing that could be a little bit better, but it all works. Who's running on-prem? Right, who has their networking solution solved? Great. Give me some good questions. But this is the kind of market we're in right now. So Kubernetes has got a presence on-prem. How are you solving your networking problems on-prem? Is anybody running on-prem and in public cloud? This was our plight. So, you know, I can bring that kind of dynamic into the conversation as well. The reality is a lot of people aren't greenfield. Right? Nobody's walking in, maybe there is a 10-person startup that's only using Kubernetes, but most people Kubernetes is complementing, or is the 10% now moving into your 100% over the next few years, right? So you're acid testing this framework, you're moving some workloads, but you're trying to get a feel for it, right, as you move it into more of a production-y environment. So this is where the market is for the enterprise. I don't know too many people who are saying, you know, just shut everything down we did yesterday, come in tomorrow morning and everything will be on Kubernetes. Is anybody doing that? Great. Cool. How's that going?
Really well.
Good. I'd love to have your luxuries. I wouldn't have as many grey hairs. So, you know, when you look at enterprise infrastructure, right, it's diverse. You don't just have container workloads, you might have VM, you might have VMware, you might have OpenStack, you might have bare metal. So can you actually tie all these things together in a contiguous networking story? Something I'm going to go through right now. So I said networking sucks, and I think when we actually go out, networking sucks in containers right now. It's actually very young and very immature. And what I actually see when I go and talk at all these different events is people have just come to accept that networking sucks and don't worry about it. It's tomorrow's problem. Right, let's get things up and running. Let's not worry about security on the network. Let's just forego the last 30 years of everything that we built just because we want containers. Is that really the right way to make decisions? I think it's an interesting concept, but when I go, people are like, we'll worry about networks later. Right, so we didn't have that luxury when I was building this. We actually had to take the paradigms that security had signed off on for VMs and bare metal infrastructure so that we had firewalling and policy-based rule sets, right, and actually bring them to containers if we wanted to go get our containers live. So that's something I'm going to drill into here in a minute. But who's accepted the reality that networking sucks in containers? It doesn't suck? Everyone thinks it's great? Okay, cool. Everyone thinks it's good. So maybe I'm doing the wrong thing. Okay, so the challenge. So what do we want to do with networking as it pertains to Kubernetes, right? We want to have this seamless experience for developers, right? They come in, they define their manifests, and the networking works, right? You don't want it to be some third-party person, some networking engineer, heaven forbid if you have to deal with those guys. They're like me, not fun. You want it, basically, you can define policy that you know is good, and it's being applied via an API in Kubernetes, and it's transparent to the users, right? So this is the experience that we're talking about here. So in a great system, you'd be able to define everything via API, and the network would do, and everyone would be happy with how things are configured because it's meeting your security requirements. So this is what we were trying to look for in our journey at Lithium. So security, multi-tenancy, scalability, redundancy, auditing and compliance, they're all things that are network functions, and some people want them and some people are happy just to forgo and just say, look, not today's problem. Does anybody have interest in those areas? Compliance, networking? Does anybody have those requirements? Yeah, so policy is a big thing, right? And how is policy being solved? I reference Brandon over here, but the Canal guys have policy, Open Contrail have policy, but very little container networking has policy that's inherently built into the platform right now, right? So I'm just trying to get some juices flowing in you guys' heads. This is the state of the play here. I'm not trying to be Debbie Downer, but let's just think about, what's out there and how we can build the best tool chain to actually provide business value with these tools. So this brings me to why Open Contrail. So our journey with Open Contrail started about 2 years ago. We had OpenStack, we had AWS. We needed AWS-style VPCs, so we needed multi-tenancy, which, AKA on-prem would be MPLS, right? You have different routing tables for different parts of your network. You have multi-tenancy down to your interfaces, and your network knows how to deal with the traffic, right? So we were solely in AWS at that point. We wanted to provide a consistent networking experience on-prem, and Open Contrail gave us VPC-style connectivity on-prem. So this was one of the biggest decisions we were making as to why we chose Open Contrail. The other, there's a lot of reasons. It's open source. Juniper are the stewards of the project, but it's open source. I can see, I can contribute, they have a community, I can make a difference, right? It's not closed and I'll never be able to look inside it. Hybrid. They did bare metal, they did VMs, they did VMware, you could plug it into ESX, they did OpenStack. Open Contrail may be associated with OpenStack, but it wasn't built for OpenStack. It integrates to OpenStack, just like something like Canal, they have, or Calico. They have plugins for Neutron, as it were. So Scalable troubleshooting. So when we looked at the Open Contrail platform, it actually had per packet flow. So you can actually see flow records, and we had a requirement to be able to actually see each packet, right? Imagine taking this into the container world and being able to see flows like you see flows between VMs or flows between bare metal. This was actually the visibility that security wanted, to be able to say these flows happened and have a record. Now, maybe this isn't your requirements again, but some people have these requirements. So there was an API to build tooling around the analytics that was there. So when we actually came to looking at Kubernetes, we went to the Open Contrail team, and at that time they didn't have a Kubernetes integration. And we said, hey, can we take this platform and actually reuse it? Because the path of least resistance for us would be to reuse this VM platform that we have driving bare metal and VMs. Can we reuse it to deliver container workloads? Because I don't know about you, but I didn't want to run an SDN for bare metal and an SDN for VMs and an SDN for containers. That is a lot of burden, and as you go burning these things in, it just imparts a lot of operational challenges. So the Open Contrail guys, I think it was Vancouver OpenStack Summit last year, we started working on it. I worked on the platform with them, and they actually have something that you can stand up. So at the end of this session, I'm going to show you a demo. If I leave you with any wisdom, it is that you can stand something up and actually play with it and see for yourself, because I'm not going to stand here for 30 minutes and convince you. You need to get your hands dirty and actually take a look at it and see if it solves what you need it to solve. And finally, we could go in and there were no extra knobs or buttons. So I'll show you how it integrates into the Kubernetes manifest, right? So pre-v13, and I don't know if anybody's looked at the network policy API, there was no way to create network policies in Kubernetes. So you'd have to infer something from the annotations in the labeling, right? So everything pre-1.3, Calico and Open Contrail work off that same paradigm. 1.3 going forward, if that API picks up, obviously they're going to port that into that being their policy engine that's creating the policies under Open Contrail.
A quick question.
Sure.
You said you're doing between on-prem and AWS. Are you doing an overlay network, or are you keeping them separate?
We were doing an overlay network, and I did several proof of concepts where I would run Open Contrail on AWS and on-prem, and actually have BGP peering between the control planes and be able to move layer 3 workloads across cloud platform. I did a demo, if I can shoot you a link, that shows you that functionality. But you could run it on top of AWS as well.
But you're not, the other thing I've seen is, are you keeping a service in the Kubernetes sense on one side of either always on-prem or always on AWS, and not trying to...
Yeah, so the question is, am I spreading a service cross-cloud provider, or creating one on one and one on the other?
That's kind of the fantasy people have, that they can make a service spread across the...
Yeah, I toyed with both ideas. So the fantasy is, you have one Kubernetes cluster that rules them all, right? And in actual fact, even internally as it plays out, just build smaller sections and discrete clusters work better for us, and we could actually aggregate and abstract that information from the user. But yeah, I just built one on either side, and I actually provisioned load balancers that could talk to both services through an API. I'd provision an ELB. So I used AWS to front the traffic. Yep. I pulled it into HA proxy that was running in Kubernetes, but I had two HA proxies on two different clusters, different subnets and different Kubernetes clusters, different APIs.
Just to make sure, right?
Yeah, no, good.
Because
thank you.
Latency, right? If you have one cluster for both,
it doesn't work.
Yeah, I just think you don't want to split your control plane. Where do you put half your etcd on this side and half on the other, and then where's your majority when the thing fails? And does your front end, how does it fail over? Yeah, Brendan's shaking his head. It's not a good idea.
Well, the context is Rentis actually demoed something like that, and everybody's like, how can we use this?
Yeah.
When you're moving workloads from one to the other way, transitioning, you can see the value in having
Yeah, so Yeah, so a lot of people are seeing values where they have workloads running on-prem in their private Kubernetes, and they can lift it up and move it, right? So this was actually when we originally looked at Kubernetes. We said we throw it on AWS, we throw it on OpenStack, we build some tooling on the platform, and on the back end it all runs the same. Whereas before, you'd go and do all this magic in AWS with CloudFormation and Bodo and all your stuff in Python, and in OpenStack you'd use all the client libraries and have a different tool chain that worked different. So Kubernetes was level playing ground, and the specific use case for us was we'd wake up one morning and somebody say, hey, we need some stuff in China or Japan, right? And we'd be able to lift a workload up and actually move it to AWS. We're not going to go build a data center overnight in Japan, right? Spin it up, put the front out there, and it would work the same. So Kubernetes gave us that flexibility, which was one of the value props with why we chose Kubernetes. So if you want to talk to me about how we made the decision, I can chat all day about it. So value, I just wanted to draw out, what was the value we saw and what Open Contrail supports today. So this is just in context of what it was doing for us, right? So our distributed router, routing information is stored on each hypervisor, right? Calico does have a similar model, but this is a distributed router, right? You do have a control plane, but there's no single point of failure in the vRouter. The control plane only exists to render the config that's fed to the vRouter. Whereas if you were to say there was a control plane in Calico, and this isn't a compare and contrast, it's just Open Contrail. So there are similarities here. Multi-tenancy, so down to the pod IP, you're in a different network. So each pod interface could be in a different network. So you have full isolation down to the Linux kernel. Inline stateful layer 4 firewall, so you can go and implement firewall rules right down to the kernel, so you don't have to push things out on the wire to hit a firewall. Decisions are being made locally.
It's IP tables based?
No, there's a kernel module that's doing flows in the kernel module. Yes?
That is actually my question. So how is that work in the container context, the kernel module for the fast?
Yeah, so kernel module is still outside of the containers. Everything I'm going to demo today, you'll see the agent runs in user space, which is containerized. The kernel module obviously can't be containerized. So, hardware integration. So if you want to put in big beefy routers that you know and love, you can make gateways that are big beefy routers that you know and love. You don't depend on the Linux kernel to be your world-class router. Right, so you can have high latency workloads, high bandwidth workloads, 10, 40, 100 gig in standard routers that are actually designed to do routing, and they will communicate with Open Contrail, whether it's Cisco, it doesn't have to be Juniper, it's all speaking BGP, right? So you can actually have those workloads run through physical routers. So in an on-prem setting, this makes sense. You don't want to have everything, for us, we didn't want our larger things running through Linux kernels. How are you getting 10, 40, 100 gig into a Linux kernel? Full-featured network services, so this may or may not be relevant, but you do have multicast. All the layer 2 stuff on the overlay worked, right? So we had some multicast services. If you were to build them again, nobody's building multicast these days, but if you live in a legacy world, multicast doesn't even exist in IPv6. But if you live in a legacy world and you actually have apps that you want to put on Kubernetes that need layer 2 and don't speak IP, you have things like multicast, also mirroring. So if you want to just put a span port in path and get the data, every piece of data that's going in without the end user knowing, you can actually just put that in. Grabbing stats. And obviously load balancing. So I just want to, since we're going to Open Contrail, I'm just going to pull out some architectural differences. If you guys have the context of Kubernetes, what changes if I'm putting Open Contrail in? And I'll pop up a quick diagram. So there's no kube proxy, right? You're relying completely on Open Contrail for your networking. So kube proxy is not needed when you run Open Contrail. Kube Network Manager is a Kubernetes Open Contrail process that listens on the Kubernetes API for network calls and translates them through to objects in Open Contrails to provide you networking. Open Contrail kubelet plugin. So if you look at kubelet, you have parameter to pass in a networking plugin, you just say Open Contrails my plugin, and it feeds the network setup over to Open Contrail to handle. And hardware software gateways. So if you want to, as I said, if you want to put a hardware gateway in, you can run it as software as well. So you can run your gateways. So the gateway would be north, south, in and out of Kubernetes clusters, what I mean by a gateway. Any questions? Nope? Cool. So just briefly, I'll throw this up. You don't have to take it all in, but this is exactly what I explained. And if you were to go into the demo that I'm going to show, actually, we're running the whole setup on Google Compute. So I'll give you the docs to actually build your own setup in several steps. You can run it on Google, AWS, or whatever your cloud of choice is. The docs are only for Google and AWS at the moment. But this is a typical setup, and it's just highlighting that on the master, you're running the Kube Network Manager, and on the nodes, you're actually running vRouter, which is the thing that does the heavy lifting for the routing on each Kubernetes node. Brings me to my favorite. After a year of doing this, what would I advocate to other people? So, you know, when we went into looking at Kubernetes and trying to solve networking, right, we sat down with a whiteboard and we said, we need this, 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 and you had a list as long as your arm, right? You can't do that, right? You just have to go in and be incremental. It's like how you do anything DevOpsy. Go with the minimum viable product. What would be the first thing we need to solve to move on to the next thing? Because if you try and solve everything in one big heap, you're not going to make it through, right? Or you're going to go squirrel for 9 months and come back and the company's disappeared. So be incremental. So when you're looking at networking, go in, play with it all. I try and do this every week. Have a look at what's out there on the market. It's a continual adjustment and taking a look at who's meeting your needs the best. So, you know, don't think that this is the only way to do something. Just keep looking, because the market a year ago is completely different to how it is now. You know, and in being incremental, get out and let your customers use it. How is it working for them? You know, one of the keys to our early success was we stood something up really quickly and we had people use it, and they started feeding back that they liked it. So, you know, while the networking wasn't something they were calling out, the fact that they weren't saying that the networking was broken meant that it was working, right? So, you know, we could actually start to see this thing play out. All right, if you guys want to get connected, feel free to go to the Slack channel. There's a bunch of people in there willing to help you and get you started on your journey, or even just get your demo up and running for you to take a look at. So I'll put these on SlideShare at the end, so you don't need to take photos. Getting started, here's the guides to stand up your own Open Contrail Kubernetes cluster and just see how it works. Everybody has a one-pager, so here's ours. All the components of Open Contrail run in containers on Kubernetes as well. So the Open Contrail control plane is running as pods. Right, the best part, demo. So I just wanted to show you a very simple use case. I'm not going to go into the nuts and bolts. If you guys want to get into that, feel free to reach out to me. Send me emails. Ask if I can come do a demo, or whatever you guys want to, wherever you guys want to take this. Now, one thing to call out, so the demo's on Kubernetes 1.2, not 1.3. So things could change pretty soon when 1.3 drops in the next few months. So just wanted to call that out. If you guys were saying, oh, you're using the network policy API? No, not today. Right, so in this
statement, would you say the 1.3 networking API is sufficient for what you're doing?
Yeah, absolutely. I think so. I mean, from what I can tell, that needs to exist because people are putting vendor-specific annotations in labels, right? So these labels are building out into things that they weren't. So it's, and you need a better way to actually say, I want, sockets, rather than I want to define more than just network names as labels. I want to say you have access to this tuple or this socket rather than just this network object, or create this virtual network. So you can be a lot more explicit.
If you go a different way.
Yeah.
If you review the spec and believe that it covers what you need.
Do you want to review it together now? I put it up here. No, I've looked at it. I think it will. But like anything, I do the 10-minute acid test. Does it work for me in 10 minutes? If no, come back several months later. But I mean, it does look promising, right? I like the fact that they're calling this out as a separate API so that we can actually do more granular things, right? The setup with having it in as annotations in manifest is doesn't have much legs.
So I'm trying to understand how you map the policy work that's going on with the API into things that might exist in the, let's call it the Contrail fabric, for lack of a better term.
Yeah.
Things that are plugged into Contrail at some other level, the service chaining, other stuff.
Yeah, absolutely.
Users that.
How about I just show you the demo and I'll try and answer that question. Does that work? So if you were to actually look at it, I'll just, before I kick off the demo, so how many of you guys know Guestbook Go? Nobody? It's in the examples, under the examples in the Kubernetes repo, so it's just a stock standard app. I would like to show you, if I was looking at controller. So the only difference here is this, right? So you have a vendor-specific annotation that Open Contrail is picking up on and creating a network name called Redis. So this is actually a pod of Redis, a replication controller, I should say, of Redis slaves, and they will be dumped in a network called Redis. Okay, so if I was to look at the master, the $1 million question is, you would expect it to be in Redis as well. You'd expect the Redis master and the Redis slaves to be on the same network. So let's just one-up ourselves here and have a look at the guestbook controller. So what I'm doing here is actually saying, I'm in network name front end, because this is the front end web app, but I need to access the services in the network called Redis. Right, so that's how you're defining your policy. You've got a front end network, you've got a Redis network. The Redis master and the slave pods are being dumped in the Redis network, and the front end web UI is dumped in front end, and you're actually writing a policy. That's a policy right there. You're saying front end can talk to Redis.
I'm using the same sort of directional hints that you guys are using for annotations right now?
So I'll show you how this plays out so you can just see what it actually maps to in Contrail right now.
But by default it's bidirectional?
Bidirectional, yep.
Okay.
Yeah. So in the early days it was like, how fine do we want to dial this in? And then when, things like policy, that starts to make more sense. Right now it was like this to that, no services, just open it up. But obviously when you go down policy path, or at least in that manifest, you can get a lot more granular. You could imagine what this thing would look like if you wrote a policy and annotations in the metadata. So the other thing I wanted to show you before I actually got into the demo was, let's see if this thing works. So this is actually Open Contrail, it's the UI here. What I'm going to show you is actually how it builds out the networks, the policies, and the ports as I do a deployment. So you'll actually see what actually happens in the Contrail world after I do a deployment. So other than those annotations in the manifest, it's just vanilla guestbook Go. If you go and check out master right now, it's the same thing. No other monkey business. Okay, so cube, CTL, create. I'm talking to myself. It's moral support. So I've just created that. Cube, CTL, get, let's just say RC pod. Right, maybe too much information. So let's just take a look at what we did here. So all we've done right now is created a guest book under the default namespace. Guest book is created 3 pods called guest book. We've got a Redis master and 2 Redis slaves, and they're all up and running. Just to show you while I'm here, here's all the Contrail control plane. So you've got the vRouter agents running on the minions, and you've got all the other elements of the Contrail control plane sitting in Kubernetes. So this is what you're going to get, and the idea of this demo is just to show you out of the box an experience if you were to spin up your own demo. So you don't have to go and build a Contrail control plane with something else and link it in. You basically just follow the doc and you get this out of the box. So if you have a look, images, right, everything's just coming from Docker Hub. Okay, so I've deployed that. What it should translate to here is if you go and take a look. Right, so network. So I built a front-end network. I've built a service Redis network, so this is where the service IPs for Redis live. A service default network, so anything that's under the default domain that's a service gets mapped into there, and then there's a Redis network. So I haven't done anything than those 2 annotations, and I've got these networks. If I was to look at ports, here's all the interfaces that the pods have. Right, so, and if you look at floating IPs, you'll see some that have 2. That's when it has a service associated to it. Otherwise, they'll just have 1. So based on whatever we've defined as a service cluster IP. And then finally, and I'm not sure if you can see all this, if you were to look at policies, right, service Redis policy. So Redis front-end service Redis. So I'm allowing the front-end network on ports any to talk to the service Redis network on ports any. Right, so I've created that policy on the fly. Is that?
Kind of, but what I was getting at is a little bit deeper, which is, has any thought to map it into the concept of users, policy, and namespaces? So you can say this particular group of user has access to the Redis versus this user does not.
Yeah, how are you doing users in Kubernetes? Has no concept. What's what?
We're fixing that.
Yeah, so yeah, enterprise feature request, users, right? And user role-based access, right? I think if that information is available, you could do it because, I mean, this concept is already happening in OpenStack, right? You have user-based security groups. There's just no concept of users in the metadata that Kubernetes has right now. So when those...
In V13 there will be.
V13. So the Contrail guys are here. Take notes. These guys are asking questions. But if that's a valid request, how users map to namespaces and namespaces map to policy, because I think policies are actually on namespaces at the moment, not on users. So that would also be a conflict of where you actually dump policies, right? So sounds like Brandon might be your man. He knows a little bit more about the user-based stuff, but yes, there's no facility to do that one too. And obviously, if I go and just take a quick look, I just threw this up. So if you go to guest book, you know it's load balanced, and if I can't spell, that's how we say hello in Australia. And if you go and grab, just for acid test, right, I have a Redis master with 2 slaves connected, which is what I spun up. So there's a baseline experience with a very standard example out of the Kubernetes repo of how you might get started and take a look at this. And you can see on the back end that we're building dynamically policies and creating these objects that are visible inside inside Open Contrail. So let me just flip back.
Given all the other knobs that exist in Open Contrail, how are you do you actually exercise any of them to this?
So the question was, given all the other knobs in Open Contrail, are we exercising them all? No. So it's basically on, I think, you know, the way to go being incremental is service the use case that people are using Kubernetes for. So other features may be service chaining. If you want to put a bump in the wire and call out to real load balancers or real firewalls, that's a feature in Open Contrail, but it's not being utilized because the API doesn't allow it. If you could define it in Kubernetes, and external types. Have you seen them? Load balancer. If you had external types and some API to actually provision the resources, or some way for Contrail to make sense and formulate what you're asking, I can't see why they wouldn't do it.
So right now you haven't done something like just allow free text blob to be passed through Open Contrail in these annotations?
No, I don't believe so. These guys worked on the code. So if that's something you have a use case for, submit it. Is that what you...
Having, virtual taps of network activity and all of that.
Right, if you could provision that, ask for a tap.
The examples I was just thinking.
Yeah, absolutely. So you'd actually have to call off an API and say, I have this port, this interface, go and pull it out of an object on the Contrail API and ask for a tap on that.
Okay, so you do separate scripts.
Yeah.
You find the running containers and running pods, and then you go call something.
Yes, because we have that facility, even in OpenStack, you can't ask OpenStack to give you a tap. So we had to build it anyway. So it was there.
Okay. There's a fundamental outstanding issue. I just want to know if you guys had solved it.
Yeah, and I think, there's a lot of interesting work in that space in Open Contrail as the service providers take it on, because that's more of a service provider request. I would say that's more common.
Yeah, the NFV guys.
The NFV guys want to do taps, right? And they want taps by API. And I also saw a submission for BGP as a service. So you can actually provision via API BGP peering.
The problem is they're chasing ephemeral containers around with out-of-band scripts. That's the reason why they...
Yeah. Forget about IPs when you're running containers, right? It's just a means of connectivity. Does it really matter?
Only if you want to tap it.
Only if you want to tap it. I'm not going to go anywhere with that one. Sure.
We don't chase containers, we chase virtual networks.
Right.
And the containers
are ephemeral inside those virtual networks. Yeah. But if you actually wanted to tap a specific pod interface, you'd have to go and figure it out, yeah. So that's all I had tonight. Open the floor to questions.